Okay guys, we've got digital SAT lesson number 10. We're talking exponents today and exponential functions. So one thing for you to copy down is the basic formula for exponential functions. And what does everything mean? A, the first number here, is going to be our initial starting beginning amount, aka y-intercept. The B is going to be the growth or decay factor. So this number is either going to be like a whole number or it's going to be a fraction or a decimal that's less than 1. And that tells you whether it's going to be a like increase or a decrease. So you're looking at the B in order to tell that. And then the X is amount of time, and usually it's expressed in years, as you'll see when we're doing some of these multiple choice questions, but it could also be minutes or hours, just depending on the context of the question. Sometimes they use a T instead of an X. I'll point that out in an equation also. Sometimes this is written as a T for time, but that's what the X kind of stands for. So I'm just going to go right into number 1. We have an equation here, and they're asking you what is the value of f of 2. Starting out really basic, that means you take the 2 and you plug it in for the x. And just make sure you're following your order of operations here. Remember that you do the exponents first before you multiply. So make sure that you square the 3 first, which makes it 9, and then multiply by 2 to get 18, okay? Basic to start. Let's do number 2. We have an equation here. Which of the following is the right graph? So one thing that you could do to a process of eliminate is that this graph, see how it's decreasing? Same with this one, it starts really high and then it gets lower and lower and lower. That's decreasing. Those are both considered decay. And this is exponential growth because the 2 is a whole number and not a fraction less than 1, like 1/2 or 1/3 or something like that. So if you remember the difference between exponential growth and exponential decay, growth should look like this, where it skyrockets as you're looking at it left to right. So we can process of eliminate, half the answers are gone right away, knowing that these two are considered exponential decay. And looking at the equation, that 2 right there tells me that we are exponentially growing, not getting smaller. You could also make a basic t-chart. I think those are sometimes pretty quick and easy to help you decide what the answer should be. When you plug in 0 for x, that makes the 2 go away because anything to the 0 power is 1. And then you multiply by 4 and you get 4. You could plug in 1 here. I made a t-chart, and you can check my numbers here. And I'm trying to decide which of the following, try and find one of the ordered pairs on the graph. Another option you could do is you could check Desmos. Okay, remember when you're given y equals, it's really quick to just check what Desmos would show. So I'm going to flip to that really quick. Y equals 4 times 2 to the x. Look at the little a to the b button next to the exponent button. That's how you get the 2 to the x there. And you can zoom in and zoom out. And I'm not sure if this, if I can split screen this, is super obvious which of the correct answers it is between C and D. But if you just match up the questions really quick, remember you can zoom in. Match up the ordered pairs. Look at the Y scale here is actually much bigger than what I have in Desmos. But if you can find this ordered pair, I believe it's 2 comma something. Where is it? Right there. 216. I just had it. But you can kind of like press your finger and drag so that you can find ordered pairs here. If you can get it right onto 2 comma 16. That's what I have drawn there. That is why letter D is the right answer and not letter C. The ordered pair 2 comma 16 is not on this. It's a little bit higher than 25. So remember, I've said many times that a lot of times you'll be able to process of eliminate 2 answers right away like this, and then you'll have to think kind of hard about these 2. Either make a t-chart or check Desmos or something to help you be confident in the right answer. Okay, for number 3, there's actually several questions where it asks you to interpret what's going on here. And so this question, it gives you some information about what the x stands for, what the y stands for, and you can tell we have exponential decay here because it's getting smaller and smaller. And it's talking years since 92. Which statement is the best interpretation of the y-intercept? So do you remember what the y-intercept looks like? It's where it touches the y-axis, which is right here. It's 9. Let's figure out what the y-intercept means. So that actually means when x equals 0, y equals 9. That's what a y-intercept is. And what was x again? Let's read through the wording of the question to decide what x was. What's labeled down here? What do these numbers represent? It says x is the number of years since 1992. So that's what I wrote here. And then it actually says estimated number of catalogs y. That's what the y value is. And so 9 is actually in thousands, so be really careful about that, is that even though this is labeled 1 to 9, each of those numbers stands for 1,000. So the 9 right here actually means 9,000. That's going to be important when we're trying to decide which of these is the correct answer. When x equals 0, that is not 10 years after 1992. That's like after 0 years. That's the beginning or initial amount. So it's not during the first 10 years. I'm crossing that one out. Letter B, the estimated total number of catalogs was 99. No, it's actually 9,000. Okay, so that's not right. Letter C, the estimated number of catalogs. Ooh, this is tricky. A lot of people might choose 9 because they're not remembering that the Y values are written in thousands. So be careful about that. It's actually 9,000 catalogs. That is why we got letter D. Okay, the end of 1992, that was T equals 0. Number of years since 92 would be 0. And the number of catalogs is 9,000. So D matches up. Number 4, same thing. What's the meaning of the 5640? So this number right here, what you wrote at the very top of the page, is that the A value, that first number, is the initial or the starting or the beginning amount. So that means that we started with 5640 something. I guess it's global traffic data terabytes, okay? So that is exactly what we started with in 2010, was exactly when they started measuring this thing. Okay, so that is why letter D is correct. It's not an increase. If we're talking about the increase, we'd be talking about the 1.9, okay, the thing with the exponent on it. And then the estimated data traffic for the year that is a certain number of years after 2010, that has to do with the T. And we're talking in the beginning, the initial, the starting, that is exactly at 2010, not years after 2010. A lot of times you can eliminate 2 answer choices right away, and then you have to think kind of hard about the difference between the last 2. Number 5, again, another interpretation. What does the value 8, 82 mean? So what does the 8 stand for? Let's read through the wording of the questions. The X value is the years after this dude purchased a coin, and like how much money is it worth? You know how if you keep something for like 100 years, the price of it like goes way up, right? If you have a coin collection or anything like that. So X is the number of years this person has had the coin, and Y is the price, predicted value of the coin, how much he could sell it for. Okay, so what does the 882 stand for? Let's read through the words pretty carefully. $82, that looks right. 8% greater. No, I'm looking for 8 years. Okay, so A is gone. Letter B, $82. Again, that looks good. $82. 8 times the predicted value. I don't think it's a multiplication thing. I don't think we're multiplying it 8 times or raising it to the 8th. It's 8 years after purchase. That's what the 8 stands for. Okay, letter C, 8 years. That looks good. Again, increased by a total of $82 versus the predicted value is $82. This one is better. It's not going up $82. It actually costs $82. So that's the difference between C and E, or C and D. So choose carefully on that one. Number 6, we've got the number of CDs being sold from this time period is decreasing. That should make sense because everyone started streaming music instead of buying CDs, right? And it's declining each year by 15%. Let's remember what we learned about percentages. If something decreases by 15%, that means that you're only paying for 85% remaining. Okay, or if the number of CDs went down 15%, that means that 85% of the CDs are being sold. Okay, so we're looking for the 85 in here. This would mean 15% is remaining, but this represents 85% remaining, and this is correct. I can eliminate these two because remember when you add 100 to it, that actually represents an increase, not a decrease. Remember what we talked about for percentages. So eliminate these 2 right away and then choose very carefully between the other 2. If something goes down 15%, that means that you have, or you're paying for, or you have left 85%. B is the right answer. Number 7, let's talk about an increase now. So we've got this formula. It's asking me what goes in for A, and A is either the number, like the percentage that is an increase or a decrease. Since we're doing an increase here, I'm going to take the 100% and add 4% to it. So be careful that we're not doing 1.4. It's actually 1.04 because 4% would be 0.4. 0.4 would be 40%. Be careful about that. And again, the A, if it's an increase, it needs to be a number bigger than 1. If it is a decrease, that is when your number would be less than 1. So that's why A and B are out. Number 8, I got a few left. We have a starting amount of students enrolled in a college, and we are declining 2% each year. So that's not good for the college, I guess, but that means that 98% of the starting amount are the ones that are enrolling. So if we lose 2%, remember we are left with 98%, and 98 is what we're going to use. This is backwards, like that has the percentage first and the starting amount first, second. Remember how if you look at the formula that you wrote on the very top of the page, the 3,000 should go first. This is wrong, this is wrong. How do we choose between C and D? 2% less means 98% remaining, so we want this one. Number 9, we have an object's kinetic energy in joules is equal to the product of... I'm stopping here, and I'm going to start writing an equation. We have kinetic energy in joules, so I'm going to put J, is equal to, so I have an equal sign, the product of, product means multiply, 1/2, so I've got the 1/2, times, let's see the mass in kilograms, so I'll use a K for kilograms, and, so I'm multiplying again, the square of the speed. So I'll put S squared. Don't put square root. Be careful about that. A lot of people incorrectly read square and put a square root symbol. Square means S to the second power. Okay, cool. Now I think we just have numbers that we need to plug in. So as I was reading this, I was writing myself an equation as I read. What is the speed in meters per second? The mass is 4K. So for K, I'm putting in 4. And the energy is 18 joules. So for J, I'm putting in 18. And then that means I'm just solving for S. So I need to leave the S as S squared. So when you take 1/2 times 4, you get 2. I'm going to divide both sides by 2 to get 9. And then when you square root it, you get 3. Brilliant. Write the equation as you read and then just plug in the numbers. Number 10, I've got something that doubles every year, every 2 years. Okay, great. So in 1985, they started measuring something and they had this many transistors. Okay, super. I'm not sure what that means or what that does, but okay. Based on this information, in which of the following years does the law estimate the number to reach 1.1 million? Okay, you can see I kind of made myself a little T-chart here. I'm not really sure how to use a formula for this one, so let me just try and think my way through. 1985, we started with this many of those things. And I know it doubles every 2 years. You see that I circled this? So that means 2 years later, 1987, this number doubled. 2 years later, 1989, this number doubled. Wait a second. Am I trying to reach 1.1 million? Oh, snap. There's the answer. Taylor Swift, 1989. Okay, great. Number 11, last one. This one's kind of a hard one. It's actually kind of simple, but it's a complex way of thinking. This is for those kids that are trying to get 700 to 800. Okay. We've got an equation, and the exponent looks kind of weird, right? T over 410. How much time does it take this thing to double? Okay, great. So I wasn't sure how to do this, but in order to help me think my way through, I just started plugging in for T equals 1 year, T equals 2 years. Okay, so when you have this 2, which represents the doubling, this is my starting amount, and I'm multiplying it by 2 to some exponent. So 2 to the 1 over 410, you can check that in your calculator. It's like a really small decimal, okay? 2 to the 2 over 410. Again, you can check that in the calculator. It's a really small decimal. And then I started thinking, oh, wait a second. What if I put 410 over 410? That makes the exponent 1. And 2 to the first power is 2. And that is what is going to double my 60,000, which gives me 120,000. So I'm pretty sure that into the box where I'm going to type this answer, I'm going to put after 410 years, or actually it's minutes, 410 minutes, this thing's going to double. When you take 410 and you plug it in for T, that makes the exponent 1, which means you're making your 60,000 and multiplying it by 2, which makes it double. So I started kind of plugging in numbers just as a way to think and problem solve. And I ended up realizing I should just plug in 410 for t. That is kind of a hard, challenging question. Maybe that makes sense now that it didn't actually take too long like I thought it was going to. But that is your crash course on exponents. Please come see us on an optional Friday if you need some more help with exponents or if I gave too brief of an explanation on this. But there's your rundown for all the problems on the exponents lesson. Thanks for watching, you guys.